Hi students, let us solve this problem. Suppose that a person of weight 60 kilograms and height of 1.4 meters reduce her sleep by 1 hour per day and spend then this extra time reading while sitting upright. If her food intake remains unchanged, how much weight will she lose in 1 year? This is a very interesting problem. So let us see, what we know. We know in this case the mass of the person, so we know the mass of the person is 60 kilograms. We know her height, there is 1.4 meters. And we know that is change in the physical activity. So is using time that was sleeping now to be reading, okay, sitting upright. And this change in physical activity is a change of physical activity of 1 hour, right? So the first is to find what is the variation in the metabolic rate of this person due to the change in physical activity. So I'm going to say that the variation in the metabolic rate is equal to the metabolic rate while sitting upright minus the metabolic rate when sleeping. According with the textbook of Davidowitz in chapter 11, we have that the metabolic rate of a person that is sitting upright is 50 calories per meter square hour minus the metabolic rate while sleeping is 35 calories meter square hour. So the difference in metabolic rate, the variation in the metabolic rate is 15 calories per meter square hour. Once we know this, now we're going to do a group of conversions. Okay, so we get my 15 calories per meter square hour. And as we want just to do this per year, so we want to see how much weight it's going to lose in a year, I will convert those hours into years, right? So I'm going to say times 1 hour per day times 365 days per year. So that is going to let me find, the number of calories per year, okay? Instead of calories per meter square hour, we're going to have calories per meter square year in the change of metabolic rate. So, of course, we are here canceling these hours with these hours, day with day here, and we're going to get calories meter square year. And that would be 5,475 calories per year meter square. Well, this is the change in metabolic rate, in a year. Let us find now the area of the body of this person. And we know that the area in meters square can be calculated using this empiric formula. Let's say 0.202 times the mass of the person to the power of 0.425 times the height of the person to the power of 0.725. If I now calculate, the area, the surface area, right, of this person, according with the mass and height, using the formula that I give you, we have 0.202 times 60 kilograms, that was her mass, right, to the power of 0.425 times 1.4 meters to the power of 0.725. Of course, now you have to use a scientific calculator. You have to be able to write 60 kilograms to the power of 0.425. So using the calculator, this function, there is x to the y, of course. So you write 60 kilograms to the power of 0.425 and 1.4 to the power of 0.725. And you multiply those numbers and multiply by 0.202. That will be equal to 1.47 meters square of area. So the surface area of the body of this person is 1.47 meters square. Well, as you see here, the variation in metabolic rate is in function of the area, so we have as change per hour, 15 calories per meter square hour. When we convert into years, we have 5,475 calories meter square year. So if we want to eliminate this meter square, we will multiply by the surface area, by the area of the person. So I will multiply, and like that, and I'm going to have my change in metabolic rate as a function of the area anymore. So I have now 5,475 calories per year times meter square times 1.47 meters square. That would be approximately, well, you can see here the meter square, 8,042 calories per year, right? So the change in physical activity represents, that this person would be spending, 8,042 calories per year more, just due to the change in physical activity. So we need now to convert this into mass, right? So we know that approximately 1 gram of fat is used for every 9 calories of deficit. Right? So you will be burning your 1 gram of fat for every 9 calories of deficit. So this person is now changing, the food that she's taking and the amount of food and the type of food, right? So respect the time when he's sleeping. Now this person we have, a deficit in calories, because there is a change in physical activity, so there is an increase in the number of calories that is now burning, right? Or that needs, So it's gonna go and burn, or use 1 gram of fat for every 9 calories. But how many calories of deficit we have per year? We have 8,042 calories per year of deficit. So basically now to convert, these calories per year of deficit, right, into kilograms, we say that 8,042 calories per year times 1 gram that you use of fat for every 9 calories of deficit times, and then we made a conversion of kilograms into grams, or grams into kilograms. So we say 1 kilogram every 1,000 grams. So we're going to be here now simplifying the calories, simplifying the grams, and we're going to find now, the weight that this person is losing due to the change in the metabolic rate, right? Due to the change in physical activity. And this will be in kilograms per year. So basically we have to get the 8,042 divide by 9 and divide by 1,000, and that will give you 0.89 kilograms. So the change in physical activity of this person that is now sleeping 1 hour less and using that time to read, sitting upright, it represents, if the diet of the person doesn't change, a reduction of weight of 0.89 kilograms, of course, per year, right? So it's going to be losing weight in the order of 0.89 kilograms just for only changing, 1 hour of reading by instead of 1 hour sleeping. So this is a very interesting problem with a lot of conversions. What I know is pretty difficult. So I ask you to watch this video carefully and take your notes. And I hope this video is going to help you to understand this problem. Thank you so much.